So yung discussion natin in this session, yung pag-uusapan natin, is all about rotational motion. So rotational motion with rotation, constant angular acceleration tayo. So yan ang ating tatalakayin within the whole period. If ever na matapos natin yan with sample problems, then we will be proceeding to some topics under dynamics like the Allenbert's principle, centrifugal force, at saka yung ah, banking banking of highway curves. So tatalakayin natin yun. So I think we have 4 topics in this session para makarami tayo. Then the following week, you will be given definitely a quiz about rotational motion, and then continuation, some sample problem regarding about Allenbert's principle, centrifugal force, centripetal force, at saka yung banking of highway curves, wherein we will also talk about the super elevation. So ano nga ba ang ibig sabihin ng rotational motion? Rotational motion can be defined as a motion of an object around a circular path. So kapag yung pathway na dinadaanan ng object is circular, then we're definitely with rotational motion. And when dealing with rotational motion, ang daming mga forces na involved, just like the word na centrifugal at saka centripetal. Later on, after ng rotational motion natin na discussion, we'll be talking also about the centrifugal force at saka ng centripetal force. Ano nga ba ang kaibaan ng dalawang yan, ng centrifugal and centripetal force? Bakit sila related sa rotational motion? If you can still recall the movie na The Speed, yung bus na pinapaandar ng bida is actually dumaan siya sa roadway na masyadong ma-curve, masyadong matarik yung pagkaka-curve niya, and then hindi naman siya puwedeng bumagal ng speed. Kailangan stagnant lang do'n sa speed na kinakailangan nang sa gayon yung bomb, hindi mag-explode during that time. So, kasi apektado siya ng centrifugal force by that time also. Kapag masyadong mabilis yung bus at hindi katamtaman lang ang takbo, may tendency kung walang barrier yung roadway, yung bridge na circular ang shape, yung form, mawawala sa posisyon yung bus. Actually, inaarang lang nung barrier kung hindi malalaglag na sa bridge yung bus, eh. Just try to recall that movie na The Speed. So, yan ang ating rotational motion, ano? Basahin ko ulit. Rotational motion can be defined as a motion of an object around a circular path in a fixed orbit. It can also be defined as the motion of a body. From the movie Speed, yung body natin doon is actually the bus itself, in which all of its particles move in a circular motion with a common angular velocity about a fixed point. So yan ang definition or brief definition ng ating rotational motion. So
Eh
para
di,
wala ba kayong
tanong po,
sige anak.
edi yung Earth po, sir, considered po siya sa rotational motion po.
Yes, kasi nagro-rotate siya sa orbit. Okay, no? Umiikot siya. May rotational motion na nagaganap sa ating Earth system. Okay, malinaw
Thank
ba,
you po.
Oliver?
Opo, sir, malinaw po.
So kung babasahin ninyo yan from other books or sa internet, makikita ninyo malimit na ibinibigay na alimbawa lagi ang Earth, yung rotation niya sa solar system sa kanyang orbit. Isang example ang Earth sa rotational motion. And even yung mga pulley lang na pinapaikot natin sa system, halimbawa sa vector analysis, di ba, yung pulley. Actually, example yun ng rotational motion kasi nagmumove ang ating pulley para ma-perform natin ang ating experiment regarding about vector analysis. So let us continue. Merong isang topic sa trigonometry na kailangan ninyong balikan. Ito yung tinatawag na length of an arc, wherein ang formula natin S is equal to R theta. Kung saan ang theta, yung angle na yon, yung central angle ng ating given sector in this position is actually in radian. Kung ang given mo nasa degree measure, kailangan i-convert mo ng radian upon calculation. Yung S, ito yung linear displacement o yung distance natin in meters. Yung R, ito yung radius ng ating circular path. Okay, can you follow? Actually, ang formula
Yes po, sir.
ng arc, yung arc is very useful. Hindi lang sa dynamics, ano? And even in surveying, you will use this lalong-lalo na kapag pinag-aaralan ninyo yung mga simple curve, yung compound curve, reverse curve, and then yung may converging and diverging tangent, parabolic curve. Very useful ang formula ng length of an arc from your trigonometry. So, ang formula ng length of an arc is actually this one. S is equal to R theta. Di ba sa surveying, meron kayong length of the curve? Yan ang formula din ng length of the curve, yung extra formula na pwede ninyong gamitin sa surveying kung natakil na ninyo yung mga simple curves and compound curves kay Ma'am Pei. I think si Ma'am Pei na ituro sa inyo yun. Sipag niya magturo, no? Umabot kayo dyan. And then let us proceed. Solve for the derivative of S para may pagpatuloy natin yung derivation ng formula natin regarding about rotational motion. Sa left-hand side ng ating given formula ng length of an arc, hanapan natin ang derivative ang S with respect to time. If I am going to take up the derivative of S with respect to time, that will be, I think, d over dt. Kasi with respect to time, d over dt of S. And sa right side ng equation, kailangan hanapin natin ang derivative ng theta with respect to time. Yan ang ibig sabihin ng WRT na abbreviation. So kung hanapan natin ang derivative ang formula na yan, ds over dt is equals to r d theta over dt. Okay? Nakakakopa pa kayo hanggang dyan? Naiintindihan ba kung bakit nag-arrive sa ganyan ang formula natin ng length of an arc?
Opo, sir.
Okay, so let's proceed. ds over dt, this is actually also the formula for the velocity. And d theta over dt, yan ang ating tinatawag na w. V is equals to RW. Later on, may papaliwanag ko sa inyo ang ibig sabihin ng variable na W. But definitely, V stands for the velocity and R stands for the radius ng ating given circular motion or rotational motion. Ang W is actually d theta over dt at ang velocity is ds over dt. Okay, so let's proceed. And then yung symbol na alpha daw is equal to the derivative of W with respect to time or dW over dt. Later on, I will introduce to you the definition of the symbol alpha. Kung ano ba yung function yan. Kung ano ba ang tawag dyan. And then A sub t is equals to R alpha. A stands for the acceleration. Pero ang tawag sa acceleration dyan is tangential. Kung merong tangential, definitely meron ding normal. Okay? Yan ang tinatawag naman nating normal acceleration is equal to the square of velocity all over r. So, tinatandaan na ninyo ang mga formulang yan buhat ngayon hanggang sa kayo ay mag-take ng licensure examination. Laging ibinibigay ang rotational motion sa licensure examination, hindi nawawala yan. So another formula for the normal acceleration is RW square. If you already have the value for W, square mo lang and then multiply mo ng R, mahanap mo na yung tinatawag nating normal acceleration. And then W dW is equals to R d theta, followed by, okay, recall muna natin yung ating tinatawag na rectilinear motion. Kung naalala ninyo sa P6, tinuruan ko kayo about rectilinear motion, yung mga nag-under sa akin sa P6 years ago. Meron tayong three kinematic equations sa rectilinear motion. And for every kinematic equation that we have under rectilinear motion, definitely may counterpart yan sa rotational motion. Kung may kinematic equations tayo sa straight line motion at saka sa free fall, sa rotational may mga kinematics equation din tayo. May pantapat din tayo at tatlo din. Sa rectilinear motion versus rotational motion, if sa rectilinear, this is our formula for the velocity is equals to the derivative of displacement with respect to time. Sa rotational, yan ang ating velocity, ang W. Can you follow? Mamaya ipapaliwanag ko ang ibig sabihin ng W velocity na yan, the derivative of theta with respect to time. Yan ang katapat ng velocity sa straight line motion. Yan naman ang velocity sa rotational motion. Ginagamitan natin ng symbol letter W. Now, if in rectilinear motion, ang formula ng acceleration natin is dv over dt, or the derivative of velocity with respect to time, same thing sa rotation, sa rotational motion. Alpha is equals to dw over dt. Can you follow? Hanapan natin ang derivative, ang velocity with respect to time, yan ang ating acceleration. Okay? Mamaya, malalaman ninyo kung anong ibig sabihin ng alpha at ng W. Sa rectilinear motion, kapag kinuhanan natin ang second derivative ang posisyon, yan ang acceleration. Kapag ang first derivative ng posisyon, ang hinahanap naman natin is velocity. Okay, let's proceed. Under pa rin ng rectilinear motion, we have BdV is equals to AdS. Ang counterpart nito sa rotational motion is WdW is equals to Rd theta. So, dapat ang mga yan, kabisado ninyo from physics up to dynamics. Wherein, yan, balikan natin ang formula ng length of an arc. S is equal to R theta. Take note, ang theta, kapag nasa degree measure, kailangan kino-convert lagi yan sa pi radian. Okay? And then, followed by, B is equals to RW. Yan naman ang formula ng ating velocity. And tangential acceleration, binalikan ko lang yung kanina, R alpha. And the normal acceleration is equal to RW square. So take note of these four formulas. And even yung rectilinear and rotational motion, yung mga equations natin. And so, yung kinekwento kong mga kinematics equations kanina, for the kinematics equation, if rectilinear motion, yan ang ating first kinematic equation under na rectilinear motion. Alam ko hindi nyo makakalimutan yan kasi tinuro ko yan sa straight line motion. And then, ito naman ang ating kinematic equation number 2. Displacement is equals to BOT plus 1 half AT square. And then, another formula, our third kinematic equation. Nakalimutan kong i-write yung square, no? May typographical error. Sulat ko lang siya. Actually, may square yan. B square is equals to BO square plus 2AS. So, let us correct the formula. Nakakasunod pa ba kayo? Hello? Are you still with me? Hello, mga anak?
Yes po, sir.
Yes po, sir.
So, may square yun, no? Nilagyan ko ng square. Nakalimutan lang i-type. Okay, so let's proceed. And then, S is equal to R theta. V is equals to RW. Inulit ko lang. Tangential acceleration is r alpha. And then for rotation, look at this. Ang counterpart ng velocity ng first kinematic equation natin sa rectilinear motion is this one. Sa rotational motion, yan ang counterpart niya. And then, proceed tayo. Ang counterpart naman ng displacement or S sa rotational motion is this formula. Yan ang katumbas niya, no? Kaya lang, dito straight line yung ikot, dito circular yung motion. And then for the third one, yan ang katumbas naman ng ating formula. Pinapakita ko lang may counterpart para hindi kayo mahihirapan na mag-memorize ng mga formula na yan. Dahil kahit sabihin man nila na kailangan kabisado yung konsepto, nakakatulong pa rin yung kinakabisado ninyo yung mga formula. Kapag lagi ninyo ginagamit ang mga yan, unti-unti makakabisado ninyo yung mga yan. Wherein, ito na ang ibig sabihin ng mga variables natin. Ang W, yun ang tinatawag natin na angular velocity. Okay? Naman yung maigi. W, tawag angular velocity. AN, normal acceleration. AT, tangential acceleration. And yung alpha, we call it as the angular acceleration. Then take note, theta, we have the angular displacement. The straight line, displacement lang siya. Sa rotational, ang displacement, duduktungan mo lang ng word na angular. Okay? Yung theta. Yung B, velocity. W, angular velocity. So, ganun lang kasimple yung pagkakabisado ng mga yan. Now, since na-introduce ko na yung mga formula na tatalakayin natin, let us try having some problems. For example, sample board exam problem number 1. A flywheel 6 feet in diameter accelerates from rest at a constant rate of 4 RPM per seconds. Compute for the following. Okay, compute the angular velocity on the rim of the flywheel after 10 seconds. Compute the normal component of the acceleration of a particle on the rim of the flywheel after 10 seconds. Compute the tangential component of the acceleration of a particle on the rim of the flywheel after 10 seconds. So, bibigyan ko kayo ng sample kung paano mag-calculate. So, ang unang hanapin natin dito is the angular velocity on the rim of the flywheel after 10 seconds. So, this is it kung paano natin isolve ang isang board exam problem example na yan. I think naibigay ito year 2000 plus na sa licensure examination sa engineering. Latest ang example na ibinigay ko sa inyo. So, paano i-calculate na yun ang angular velocity? So, for our solution, paano ba hanapin ang angular velocity? So, first and foremost, kailangan alam muna natin yung mga given natin. Yung R is 3 feet. Bakit 3 feet ang R? Palagay ninyo, bakit ang R is 3 feet? If you will read again the statement of our given problem from the very beginning. Ano kaya yung dahilan? Bakit 3 feet ang R? Hello? Why is it the radius of the flywheel in a circular motion is 3 feet? Alam ba nani, ano yung dahilan? Bakit 3 feet? Saan ang galing yung 3 feet? Meron bang 3 feet na given sa problem? Jalin? Meron bang nababasang 3 feet sa given problem? Paano nahanap yung radius sa 3 feet?
Sir.
Yes. Saan ang galing yung 3 feet? Bakit nilagay ko radius 3 feet? Ano yung reason?
Yung sa diameter, sir,
Yung
kalahati.
radius,
Okay, yung kalahati ng diameter. So, 6 feet yung diameter. Ang diameter ng bilog, ang kalahati nito is radius and that is equivalent to 3 feet. So, next. Yan. So, alpha now is equals to 4 times 2 pi over 60. Ano ba yung 4? That is RPM per seconds. And then, multiply ko ng 2 pi over 60. At ang nakuha ko is 0.42 radian per second square. Ano ba yung formula ng alpha? Kung babalikan natin kanina, ang formula ng alpha, ito siya. Angular acceleration. Balikan natin yung formula no, para makita niyo. The derivative of W with respect to time. Okay? Derivative of W with respect to time. Or alpha is equals to tangential acceleration over R. Over R. Yung formula sa taas. Analyze nga natin. Multiply ng 2 pi yung radius, yung alpha. Ano bang ibig sabihin ng alpha kasi? Kung nakikinig kayo kanina. Plus, anong ibig sabihin ng alpha? Hello? Ano ba yung 4? RPM per seconds. Is it that is the angular velocity? Tama ba yung W? Kasi RPM per seconds eh. Di naman nakasquare yung seconds. Hello? Okay, so let's continue. Wala sumasagot. So alpha is equals to 4 times 2 pi over 60. So yan ang value ng ating alpha, 0.42 radian per square seconds. Then we have to calculate for A sub n. RW square ang formula natin for our normal acceleration. And then yung kinematic equation natin is W is equals to W sub O plus alpha T. Direct substitution. Mahanap natin yung ating W na angular velocity. Hello class, are you still with me?
Yes po.
Kailan kayo ha? Saan lang galing yung 60 degrees? 60 yung baba, di ba, no? 2 pi over 64. Wala siyang figure eh. Okay, 4 RPM per seconds. Kinupit yung alpha. Okay. Nag-guess ba ninyo yung angular velocity? Paano na-calculate?
Yes po.
Kinupit mo na yung alpha. After na-calculate yung alpha, substitution na lang doon sa kinematic equation natin. So let's proceed. So we have now the normal acceleration. So ibinigay ko yung formula ng normal acceleration kanina. Ayan siya. Meron na tayong given radius with strip it. And nahanap natin yung angular velocity. So direct substitution lang sa ating normal acceleration. Ang dali lang pala nito eh. Then we can have now the normal acceleration for our second question after 10 seconds. Ibig sabihin, 52.92 FPS after 10 seconds. Yan ang ating normal component of the acceleration of a particle on the rim of the flywheel. And then, para sa ating tangential acceleration, we also have a formula for this. A sub t is equals to R alpha. So, direct substitution tayo. 3 times 0.42. Nasolve na yung alpha kanina eh. Diba? And that is 0.42 radian per second square. So, ang ating tangential acceleration is 1.26 fps square. So, yan ang ating sample problem number 1. As simple as that. Wala siyang kahirap-hirap unlike yung mga sinaunang mga problem solving natin. Okay, we have sample problem number 2. The rim of a 50 inches. Pakibasa nga, Oliver, para may iba naman yung boses.
The rim of a 50 inches wheel on a brake shoe testing machine has a speed of 60 miles per hour. When the brake is dropped, it comes to the rest after the rim has traveled a linear distance of 600 feet. What are the constant angular acceleration and the number of revolutions the wheel in coming to rest?
Okay, tinatanong yung number of revolutions. Number of revolutions stands for the number of ikot nung wheel. Can you follow? Yung ikot nung wheel. Bawa dito siya nagsimula, ikot sa 2, 3, ilang revolution ba ang kailangan para ito ay tuluyang mapunta sa rest. Okay. Ang linear distance of 600 feet, ito yung ating tinatawag na S. Kumbaga, sa length of an arc, ito yung S. Ito yung displacement natin. Can you follow? In a certain angle, with respect to a certain angle. So, okay, kung isosolve natin ang given problem na yan, paano hanapin ang constant angular acceleration and the number of revolution the wheel makes in coming to rest? Okay? Based from our given, una, ang ating velocity or speed. Sa problem, ang pagkakasaad is speed eh. Pero dapat ang sinulat sa problem, velocity dahil may direction naman ng rotation. So 60 miles per hour ang bilis, ang tulin. So what are we going to do with the miles per hour? Sa given problem, ganito ang pagkakasolve. Kinonvert ang velocity sa feet per seconds. Bakit? Simple lang ang dahilan dyan. Maybe ang mga choices nasa English system, nasa feet per seconds. Ang pinagpipili ang mga choices, ang unit na ginamit, iba. So, kailangan i-convert muna natin into feet per seconds. And one thing, yung isang unit natin dito nasa feet. So, mapipilitan tayo na i-convert ang 60 miles per hour sa feet per seconds. Can you follow? Hindi nyo ba alam na ang 1 mile is 5,280 feet? That is why 60 times 5,280 over 3,600. Okay? And then, kapag kinalculate natin ang R naman, bakit 25 over 12? Sige nga, bakit ang R is 25 over 12? Analyze the problem. Gusto ko lang makarinig sa inyo. Bakit naging 25 over 12? Tapos ang sagot, yes?
Sir, ano po kasi, yung 50 inches po para pong diameter yan. So,
Yes.
ginawa po niyang radius, kaya po 25. Tapos po, para i-convert po yung inches to feet, kailangan mo po siyang i-divide sa 12.
Exactly. So that's very good. Yung 50 inches is actually the diameter of the wheel and the half of it is actually the radius. It is actually equivalent to 25 inches. Kaso, katulad ng sabi ko kanina, dahil isa sa mga unit ng mga given is nasa feet, so mapipilitan tayong i-convert ngayon ang radius sa feet. Maybe, possibly, ang mga choices nasa feet, yung mga sagot, or feet per seconds, or feet per square seconds, yung mga nasa choices. So, na-convert na natin pareho ang velocity at ang radius sa feet per seconds and feet respectively. So, continuation ng ating calculation, V is equals to RW. Formula yan kanina na in-introduce ko. So, given the fact na given ang velocity at saka yung radius, makakalculate na natin ang W, which is actually our angular velocity. Tama ba? Angular velocity yan. Okay, so direct substitution, we can have now our angular velocity as 42.21 radian per second. After then, Since na-calculate na ang angular velocity, okay, let us proceed to the formula of the length of an arc. Bakit kailangan natin ang formula ng length of an arc? Para makalculate natin ang theta. Di ba yung kinematic equation natin kanina sa angular velocity na ipinakita ko kanina, kung babalikan natin, ito lang siya, no? Ito, nasan ba yun? Balikan ko lang. Yan, ito ba? Sa taas. Ito, di ba? Okay? And then, this also one. Tandaan niyo yung dalawang yan, no? Okay, balikan natin yung problem ngayon. Yan. So, nakalculate natin ang ating theta and we have it as 287.77 radians. And actually, we can convert it also into degrees, no? Okay, 287.77 radians ang nahanap natin. And then, yan. Using this kinematic equation, yung third kinematic equation, mahanap na natin ngayon ang angular acceleration dahil may value na tayo ng angular velocity and also ng theta ng ating radians na unit. Okay. Ang ating final velocity is 0 kasi ihinto eh. Tama? Coming to rest. That is why our final angular velocity is 0. Ang initial natin is yung nahanap nating 42.21. That time na uminto sa kakaikot ang ating wheel, definitely ang final velocity nito is 0. Okay? So let's proceed. So direct substitution ng alpha, makakalculate natin, lagyan na natin ng konting algebraic ability sa